Okay. We started working with quadratic equations our last lecture. And we found that a quadratic equation is in the form of ax squared plus bx plus c equals 0. Where a cannot equal 0 because you will not have a quadratic. You lose the x squared term. Now, we found out that one way of solving quadratic equations is by the factoring method. What you do is you get them in general form, you then factor, set each factor equal to 0, and solve those two simple equations. Now, first of all today, we're going to start off with what's called a pure quadratic.
Can we back up?
Yes.
Got a question on homework.
Can you hold it to the end? Because this is a long lecture and I want to make sure I get it. And then if we have time, if not, I can always cover it on Monday to review. Okay? A pure quadratic is one in which b is equal to 0. b is equal to 0. Example. X squared minus 4 equals 0. This is a quadratic equation. Notice b is 0. If b is 0, that means you're not going to have a first degree term. Now, we know how to solve this. We can do it by the factoring method. We can factor x squared minus 4. We come out with x plus 2. X minus 2 equals 0. Set each factor equal to 0 and solve them. We come out with x equal negative 2, x equal positive 2. We know that. Now, anytime we have a pure quadratic, there's another way we can attack the problem. What we can do is we can isolate the square term, get it all by itself. Isolate x squared, get it all by itself. Well, if I do that, I have x squared equal 4. Okay? Now, this is an equation. We have all kinds of freedoms in an equation. We're allowed to do anything we want to one side. As long as we do the same thing the other side, it's okay. So what we're going to do is we're going to take the square root of both sides. Take the square root of both sides. The square root of x squared would be x. The square root of 4 would be 2. Right. What you get when you take the square root, always, you get plus or minus the square root of that number. Always. Well, we know that the square root of 4 is 2, so our answer is plus 2. Negative 2. Same thing. So anytime you have a pure quadratic, just isolate the square. Then take the square root of both sides, you have your answer. Let's suppose we have x squared equal 100. Kathy, what is x going to equal?
10. Plus or minus.
Remember, always plus or minus 10. Plus or minus. You get plus or minus the square root of 100. The square root of 100 is 10. You get plus or minus 10. X squared equal 49. What would x equal there, Kathy?
Plus or minus 7.
X equal plus or minus the square root of 49. Well, that would be plus or minus 7. That's simple. Let's suppose we have this. Four x squared equal 25. What would x equal in this problem? Tony?
Plus or minus 5 halves.
plus or minus 5/2. Very good. How do we get that? Well, what we want to do, Lynn, is get x squared all by itself. So that means we're going to have to divide both sides by 4. You get x squared is equal to 25 over 4. We're now going to take the square root of both sides. We get x equal plus or minus the square root of 25 over 4. Now remember, when we took the square root of a fraction, we had a property that says the nth root of a over b is equal to the nth root of a over the nth root of b. So this is equal to plus or minus the square root of 25 over the square root of 4, and there's our answer. Plus or minus 5/2. Here we have a problem. 9x squared is equal to 100. What would x equal in this problem? 9x squared equal 100. What would x equal? Help. Help. My goodness, I'm drowning. I'm dead. 10/9. No. Wrong.
10 third. 10 square root mean 10 over third.
Plus or minus.
Plus and minus.
Right, but not that. You're only half right. You see, we have x squared is equal to 100 over 9. Therefore, x would equal plus or minus the square root of 100 over 9. Take the square root of the numerator, that's 10 over. Don't forget to take the square root of the denominator, Tim. 3. Okay? Two x squared equal 14. This should be interesting. Babe, you have something?
X equals plus or minus square root of 7 over 2.
No, no, no. So close though. Lynn, give us your answer.
X equals plus or minus 7?
No, no, no. If you both...
Yeah.
Frank. Tony.
X equals plus or minus the square root of 7.
Period. First of all, we want to get x squared all by itself, so we're going to divide both sides by 2. Babe, if we divide both sides by 2, we get x squared equals 7. Okay, Lynn? Now we're going to take the square root of both sides, same as we did in all the previous problems. We get plus or minus the square root of 7. Can we do anything with that? No. No. That's our answer. Okay? Let's try this one. 3x squared is equal to 24. Okay. Kathy?
I don't know. I don't know, I have plus or minus 4.
Plus or minus 4. I didn't have that. Wong?
Okay, x equal plus and minus square root 8.
Yeah,
Kinda.
but. He found the but.
Okay, but plus and minus 8.
No, I saw you doing it, Juan. Tony?
X is equal to plus or minus 2 square roots of 2.
Yeah, I saw you breaking it down there. I know, I saw that. First of all, we divide both sides by 3. We get x squared equal 8.
I'm scared.
We now take the square root of both sides. We get x equal plus or minus the square root of 8. But anytime a radical can be simplified, it must be simplified. By the way, 4 times 4 is not 8.
No, I know.
We have 2 times 2 times 2. We can pull a 2 out, and there's our answer.
Oh,
Okay?
you know I get the right answer, but I'm scared to tell you.
Don't be scared. I won't hit you today. But that's on tape. I won't hit you tomorrow either. Okay? One more. Two x squared over 3 is equal to 4. Lynn, what'd you get for an answer?
I got x equals plus or minus the radical 6.
Very good. Plus or minus the square root of 6. How do we get it? Well, we solve this as we would any equation. First step would be clear fractions. We have fractions. We multiply both sides by 3, and if we do that, we come out with the equivalent equation, which is 2x squared equal 12. Now remember what we're trying to do. We're trying to get x squared all by itself. So we're going to divide both sides by 2. If I do that, I get x squared equal 6. We now take the square root of both sides. We get x equal plus or minus the square root of 6. There's nothing we can do with that, so we're finished. That is our answer. Okay? Any questions on it? On the board we have a little equation. It says the quantity x minus 3 squared is equal to 25. Our job is to find x. Now this is a form of a pure quadratic. This is similar to all the problems we just got done working. What we're going to do is we're going to take the square root of both sides. If I take the square root of this left side, what are we going to get? Kathy? X minus 3. If we take the square root of the right side, Kathy, what are we going to get? Kathy?
Oh, plus or minus.
Plus or minus 5. Remember, that's important. Because otherwise you're only going to get one answer. We're going to have two here. Now what we do is we have two equations here. What this is saying is x minus 3 equal positive 5 and x minus 3 equal negative 5. Two simple first degree equations. Very trivial. We get x equal 8 and here we get x equal negative 2. And there's our solutions. Check them. 8 minus 3 is 5. Square is 25. Negative 2, negative 3 is negative 5. Square is 25. It checks. Okay? Let's try some. Let's try it. Quantity x plus 4 square is equal to 49. Okay, what do we get for the answers here? Tim?
X equals 5 or minus 9.
5 or minus 9? I didn't get that. I know where you came from and how you got that. It hurts a little bit. Here we go, Tim. What would be the square root of x plus 2 quantity square? X plus 4 quantity square.
X plus 4.
No.
X minus 2.
No. What do we mean by the quantity x plus 4 square? What's that mean? Multiplied by what?
Square root.
No.
By itself.
By itself. So it means x plus 4 times x plus 4. What would be the square root of that then? Back ups, Tim. Let's suppose we have x squared. X squared. What's that mean?
X squared.
Yeah.
Square root of
Now what does x squared mean?
X
Go ahead.
times X.
X times x. What would the square root of that be?
X.
X. In other words, x squared is x times x. The square root would be one of them. Suppose we have y squared. What does y squared mean?
Y times
The square root of that would be one of them, right? What does the quantity x plus 4 squared mean?
X plus 4 times X plus 4.
What would the square root of that x plus 4 quantity squared be then?
X squared plus
What?
X squared.
No!
X. plus 16.
No.
That's not
No. Here, Tim. X squared, you told me, is x times x.
right.
And the square root of that would equal one of them, x, right? Y squared is y times y. And the square root of it would be one of them, which is y. Quantity x plus 4 squared means quantity x plus 4 times x plus 4. Therefore, the square root of it would be... Thank you. So therefore, if we take the square root of the left side, we're going to come out with x plus 4. If I take the square root of the right side, I get plus or minus, always plus or minus, 7. We now solve that for x. We have two answers. We have x plus 4 equals 7. X plus 4 equals negative 7. Two very, very simple equations. We solve each of these. We get x equal 3. We solve this one. We get x equal negative 11. Let's try another one. Let's suppose I have 2x minus 5 quantity square equal 81. The quantity 2x minus 5 squared is equal to 81. There we go. Okay, what do we get for the answers? Kathy?
X equals 7 and negative 2.
7 and negative
2.
2, correct. This is a form of a pure quadratic. We're going to take the square root of both sides. If we take the square root of the left, we get 2x minus 5. If we take the square root right, remember always, plus or minus the square root of 81, which is 9. We now have two equations. As I said, you always have two easy, very, very trivial equations. You solve these, you get 2x equal 14, x equal 7. Solve this, you get 2x equal negative 4, x equal negative 2. And there's the solution. One more of these. One more. Let's suppose I have the quantity x minus 3 squared is equal to 7. I think this one was a little easier than the preceding problems. Okay, if we take the square root of both sides here, if I take the square root of the left, I get x minus 3 equal plus or minus. If I take the square root of the right side, I get what? Square root of 7. I don't get 7, I get the square root of 7. We now solve this. We have two equations. We have x minus 3 equal plus the square root of 7. X minus 3 equal negative the square root of 7. We solve this. We get x equal. Add 3 to both sides. We get 3 plus the square root of 7. Here, if we add 3 to both sides, we get 3 minus the square root of 7. And there's the solution set. And this is proper form. Now, I noticed that some of you had 7 plus square root of 7 plus 3, which is equally correct. But sometimes you get confused whether that 3 is under the radical or not. This way, there's no problem. Okay? Now, let's suppose I have x squared plus 6x plus 9. Three-termer. And what I like to do is I like you to factor that. Just factor it. What do you get when you factor that? What do you get when you factor that, babe?
X plus 3 squared.
You get it factors into x plus 3 times x plus 3, right, babe? Okay, so remember, x squared plus 6x plus 9, all that is a number. And it factors into two identical numbers. Anytime you have a number that factors into two identical factors, that number is a perfect square. 25 is a perfect square because it factors into two identical factors, 5 and 5. 36 is a perfect square because that can be factored into two identical factors, 6 and 6. 20 is not a perfect square. It cannot be factored into two identical whole number factors. Okay? Therefore, this is a perfect square, and we can write that as the quantity x plus 3 squared. That's what Beep said it was. Okay? On the board I have an expression. It says x squared plus 10x. What I like to do is I like to add a number to this so that I have a trinomial, a three-termer, that is a perfect square. What number? Positive 25, Lynn? You sure? Yeah, I thought you were sure. It's right. Positive 25. That's what she added. Okay. Let's try another one. X squared minus 16x. What are we going to have to add there in order to make it a perfect square? Tony?
Plus 64.
Plus 64. I agree. Very good, Tony. Let's try another one. Let's suppose I have x squared minus 20x. Tony, what are we going to have to add here in order to make it a trinomial that's a perfect square?
Plus 100.
Plus 100. Very good, Tony. I'm impressed. I don't know how you're getting this. I don't even know if you know how you're getting, but we'll find out. There we go, Tony. X squared plus x. And what I like to do is I like to add some number to this so that I have a three-termer that is a perfect square. Tony, what number? Plus. Good start, Tony. Plus. Plus what?
6.
Nope, it can't be. We add x's here. Can't add x's there because if we do, we get 2x. That doesn't help us. Number. 1/2? Nope. Close.